as we have studied in previous classes, how to add to complex number and various other operations. Today we will discuss about the conjugate of a complex number and modulus of a complex number. So let us start. First of all, I am going to discuss about conjugate of a complex number. So first of all, I am trying to define what is conjugate. It is the image of a complex number on real axis as shown in the figure. X-axis, Y-axis, and suppose this is the point P with coordinate xy. In previous classes we have learned that this point is equivalent to the complex number z is equal to x plus iota y. If PM is perpendicular, then this distance is x and this one is y. So we have to find the image of this point along real axis. Certainly it will be P dash with coordinate x and minus y. So if this point is P dash x minus y, then this will be equivalent to a complex number x plus iota and minus y, which is x minus iota y. This complex number is known as conjugate of z and we denote it by z bar. Here z bar is the conjugate complex number. So dear student, in short, what we learned? We learned that if z is equal to x plus iota y be any complex number, then its conjugate will be z bar is equal to x minus iota. So you have to remember it that z is equal to x plus iota y is a complex number, then its conjugate is x minus iota y. Let us take an example. Find conjugate of 1 minus iota. Students, here you can see that the complex number z is 1 minus iota, means 1 plus iota into minus 1. Therefore, the conjugate of z will be the conjugate of 1 minus iota, and as we have learned here that if x plus iy is the number, then conjugate is x minus iy, means we have to change the sign of imaginary number only. So here you can see that imaginary number is minus 1, so its conjugate will become 1 plus iota. Minus and minus becomes plus. So I think you have learned how to find conjugate. Have you get it? Okay, very good. Now we will discuss some properties of this conjugate. if z is equal to x plus iy, then conjugate of z is x minus iy. Now, number 1, z conjugate or conjugate means if you find conjugate of conjugate, then what will we get? X minus iota y is the value of conjugate z, but we have to find the conjugate again. What do you think? What will we get? It becomes x plus iota y. Very good. But x plus iota y is the value of z. So my dear student, we conclude that conjugate of conjugate is nothing but the complex number itself. Number 2, what will we get if we add a complex number to its conjugate, means z plus z conjugate? Clearly you can see here z is x plus iota y and conjugate is x minus iota y, plus minus cancel, then it is 2x. But as you know that in the complex number z is equal to x plus iota y, x is the real part of z, so I can write it as 2 real z. So the property will be z plus z conjugate is equal to 2 real z. Property number 3, what will we get if we subtract it? Z minus z conjugate. Clearly it will be x plus iota y minus x minus iota y, x plus iota y minus x minus minus plus iota y minus x plus x cancel, so 2 iota y. Again we know that y is the imaginary part of complex number z, so z minus z conjugate is nothing but 2i imaginary z. Okay, therefore z minus z conjugate is equal to 2i into imaginary z. Let us move to some other properties. I think you have noted down all. Property number 4. What is the value of z into z conjugate? It is x plus iota y into x minus iota y, and by the formula a plus b into a minus b, it is x square minus iota square y square, and iota square is minus 1, so minus minus plus. So z into z conjugate is x square plus y square. Here you have to remember one more formula I am going to discuss just after this, that is modulus of z, indicated as mod z, is nothing but under root x square plus y square. Don't worry, I will show you what is modulus z, but for the instant just remember it that modulus of z is under root x square plus y square. By the sake of this formula, can we write it as z into z conjugate is equal to under root x square plus y square and whole square. Whole square and root cancels, so it is x square plus y square. It means z into z conjugate is equal to under root x square plus y square is the value of mod z, so mod z whole square. Property number 5. Z1 plus Z2 whole conjugate will be Z1 conjugate plus Z2 conjugate. You can verify these relations very easily. Z1 minus Z2 conjugate is equal to Z1 conjugate minus Z2 conjugate. Z1 into Z2 whole conjugate is equal to Z1 conjugate into Z2 conjugate, and the last one is Z1 by Z2 whole conjugate is equal to Z1 conjugate divided by Z2 conjugate. So these are the properties of conjugate of a complex number. Getting all this? So let us move to some questions based on conjugate of complex number. I am going to take one question. The question is, if conjugate of a complex number is -2 plus 3 iota, find the complex number. So in this question, you can see that conjugate of complex number is -2 plus 3 iota. Means -2 plus 3 iota is the value of conjugate of z. And we have to find the value of complex number. Means what is z? It is to be determined. So as you have seen in the properties, we have z conjugate whole conjugate is z. So z will be, the value of z conjugate is -2 plus 3 iota. It is the value of z conjugate, then whole conjugate. So z will be -2, and for this conjugate sign of imaginary number changes. So -2 minus 3 iota will be your answer. So it is a very simple question. Have you understood? Okay. So let us move to one more example. Then we will discuss upon modulus of complex number. If z is equal to 2 plus iota by 3 minus iota whole square, find conjugate of z. So what will we have to do in this question? Here you can see that z is not in the form of x plus iy. So our first task is to convert this complex number in the form of x plus iota y. So since z is equal to 2 plus iota, I am going to expand the square, a minus b whole square, a square plus b square minus 2ab. It will be 2 plus iota, 3 square is 9, iota square minus 1 and minus 6 iota. In the next step it is 2 plus iota, 9 minus 1 is 8 minus 6 iota. So in previous video you must have learned how to divide these two complex numbers. For division, we have to multiply the numerator and denominator both by the conjugate of denominator, that is 8 plus 6 iota. So I am going to multiply 8 to the 16 plus 12 iota plus 8 iota plus 6 iota square, and in denominator it is 64 minus 36 iota square. In the next step, 16 and iota square is minus 1. So minus 1 into 6 will become minus 6. So 16 minus 6 is 10, and 12 plus 8 is 20 iota whole divided by, again iota square is minus 1, so minus minus plus. So 64 plus 36 is 100. Very easily you can see that 10 can be taken as common, or you can separate it. Then 10 by 100 is 1 by 10, and 20 by 100 is 1 by 5 iota. So this is the value of z. Now conjugate of z is 1 by 10 plus 1 by 5 iota whole conjugate, and 1 by 10 on conjugate sign will be changed, minus 1 by 5 iota. This is the answer. So I think you have learned all. Okay, very good. So we will discuss the modulus of complex number in our next video. Thank you for watching.